Atomic bombs, also known as nuclear bombs, are immensely powerful weapons that operate on the fundamental principles of atomic physics. To comprehend atomic bombs, we must first understand atoms themselves. Atoms are incredibly tiny particles that make up everything around us, such as air, water, and even ourselves. At the heart of each atom lies a nucleus, which is made up of positively charged protons and neutral particles called neutrons. Now, imagine splitting an atom's nucleus into two smaller parts. This process is called nuclear fission, and it releases an enormous amount of energy. The trick lies in finding the right atoms to split. In atomic bombs, scientists use a specific type of atom called uranium-235 or plutonium-239. These atoms are said to be fissionable because they can undergo nuclear fission. When one atom's nucleus splits, it releases a couple of neutrons. These newly freed neutrons can then collide with nearby atoms, causing them to undergo fission as well. This sets off a chain reaction, with each fission producing more neutrons that continue to split other atoms. The process rapidly escalates, resulting in an exponential release of energy. This is the principle behind atomic bombs. To sustain a chain reaction and create an explosive force, the amount of fissionable material needs to reach a specific threshold. This amount is known as the critical mass. If there is too little fissionable material, the chain reaction fizzles out, but if there is enough, a cataclysmic explosion can occur. Atomic bombs are ingeniously designed to bring the fissionable material together and maintain the critical mass needed for a powerful explosion. They typically consist of two main components, the core and the explosive trigger. The core, also known as the nuclear pit, houses the fissionable material. It is usually a sphere or a cylindrical shape made of uranium-235 or plutonium-239. The core is carefully designed to maximize the chances of a sustained chain reaction. Surrounding the core is the explosive trigger, which is typically made of conventional high explosives. These explosives, when triggered by a precise mechanism, create a powerful shockwave that compresses the core. The compression increases the density of the fissionable material, helping to reach the critical mass and initiating the chain reaction. When the core reaches the critical mass, the chain reaction becomes self-sustaining, and an immense amount of energy is released. This energy manifests as an explosion, generating an intense blast wave, extreme heat, and a blinding flash of light. The destructive power of an atomic bomb can level entire cities and cause widespread devastation. Atomic bombs harness the energy locked within the nucleus of atoms through a process called nuclear fission. By splitting the nucleus of fissionable atoms like uranium-235 or plutonium-239, a chain reaction is triggered, releasing an extraordinary amount of energy. The design of an atomic bomb carefully orchestrates this chain reaction by creating a critical mass through compression, resulting in a devastating explosion. Understanding the basic principles behind atomic bombs helps us appreciate the immense power of these weapons and underscores the importance of seeking peaceful solutions to conflicts.